So we're starting a new unit on function tables and inequalities. And our first lesson is on function tables. Go ahead and scan your lesson and list two headings you would use to make an outline of the lesson. So two of them that you could have used were find the output for a function table and find the input for a function table. So that should let you know that we're going to be using a function table and finding the different components of it. In your real world link, we get sort of an introduction to how function tables work. It says science. A ruby-throated hummingbird beats its wings about 52 beats per second. Pause the video now and go ahead and fill in these exercises. All right, let's see how you did. In the first one, we're supposed to make a table showing how many times this bird beats its wings in 2 seconds. Well, if we look at the table, 2 seconds is the number of seconds, and then the next column has that S from the first column in multiplication expression. So we're going to take that 2 and replace the S with the 2 and multiply 2 times 52, and that should give us the number of wing beats in 2 seconds. So we should have gotten 104. So we're going to follow that same pattern all the way down the exercises. For 6 seconds, we're replacing S with 6 and multiplying. We should have gotten 312. For 20 seconds, we would still multiply 20 times 52, and that would give us 1,040 beats in 20 seconds. Wow. And then the last one, it says, a giant hummingbird beats its wings about 10 times per second. Make a table to show how many times the giant hummingbird beats its wings in 30 seconds. So they switched it up on us just a little bit. Seconds is the same S, and we're using 3 seconds. Here, we're replacing S with 3 and we're multiplying times 10 because now we're dealing with a different hummingbird whose wings beat 10 times per second, and 3 times 10 gives us 30. So for the giant hummingbird, it can beat its wings 30 times in 3 seconds. We're going to be using this same idea in a function table. Take each of these individual exercises and put them all together, and that's essentially what a function table looks like. So, to find the output for a function table, we first need to understand what some words mean. We've got some new vocabulary. So, a function, which is a word that I've been using quite a bit since the lesson started, is a relation or relationship that assigns exactly one output value to one input value. The number of wings, a number of wing beats, that would be the output, depends on the number of seconds input. So, whatever the number of seconds is, changes the number of wing beats. The function rule describes the relationship between each input and output. You can recognize the input-output values and the function rule in a function table. So, we're going to look at the table and see how the input-output values are organized. In a function, the input value is also known as the independent variable. This is also something that you'll kind of learn in science. The independent variable. Independent means does not get influenced. It does not have anything that would change its value. So the input value is known as the independent variable since it can be any number you choose. The value of the output depends upon the input value. So the output value is known as the dependent variable. So independent variable, that's the one that does not change. The dependent variable changes dependent upon the independent variable. So the dependent variable is dependent upon the independent variable. The output is dependent upon the input. I know that's a lot of talk, but we'll look at a function table and see what that really means. In example number 1, we kind of get those ideas. Number 1 says the output is 7 more than the input. So from that, we're going to be able to construct a function table. So let's complete a function table for this relation. The output is 7 more than the input. So let's see. The function rule is x plus 7. Look at the table here. We've got inputs. Input is the x value in the expression. We're going to add 7 to it because it says the output needs to be 7 more. And that's going to give us the output answers. So what are the input values? if we look in the input column, we see 10, 12, and 14. Input values are possible values for x, right? Okay, now it says, why do you think these values are called input values? Input. These are the values that you literally put in for the variable. So every time we're solving for a function rule or an expression, we're taking the input values and putting it in place of the variable. And that's going to give us another set of values. So if the output is 7 more than the input, what is the function rule? Well, the function rule is x plus 7. 7 more than the input. And if x is the input, we're going to add 7 to it for that more than. Writing a function rule is like writing an expression. More than is from when we practice writing expressions. All right, so how can you find each output value? We're going to add 7 to each input. So that means we're going to add 10 plus 7, 12 plus 7, 14 plus 7. So the quantities that we get as our output values are 17 because 10 plus 7 is 17, 19 because 12 plus 7 is 19, and 21 because 14 plus 7 is 21. Now, remember, we learned a bunch of vocabulary a second ago. Which quantity is the dependent quantity? That's the output. So these values are dependent upon the input values, or the values for x. When x is 10, the output is 17. When x is 12, the output is 19. When x is 14, the output is 21. So these are all possible values for the input, and these are all of the possible outputs given these inputs. All right, so try this on your own with example number 2. It says the output is 5 times the input. Now remember, the rule is just like coming up with an expression. So think about what times means. Pause the video and try this on your own. All right, let's see how you did. So, what are the input values? Well, if we look at the input column, we see that our input values are 8, 10, and 12. Okay, so if the output is 5 times the input, what's the function rule? The function rule is 5 times x, where x is the input value. So 5 times x is our function rule, 5 times x. How can you find each output value? We're going to multiply each of our input values times 5. 5 times 8, 5 times 10, 5 times 12. Okay? So when we do that, we get 40, 50, and 60 as our output quantities or output values. Which quantity is the dependent quantity? Those are the outputs. These are all dependent upon what x is equal to. When x is 8, the output is 40. When x is 10, the output is 50. When x is 12, the output is 60. But it's all dependent upon what values we have for x. Pause the video and try these 2 function tables on your own. So we're completing the function tables given the input values and the function rules. Okay, let's see how you did. In A, our input values are 4, 7, and 10. Our function tells us that our output needs to be 4 less than the input. So we're going to replace 4 with x and subtract. 4 minus 4 gives us 0. We're going to replace x with 7, and 7 minus 4 is 3. We're replacing x with 10, and 10 minus 4 is 6. So our dependent values or our output values are 0, 3, and 6. In B, our input values are 0, 2, and 5. Our function rule is 3 times the input value. So 3 times x is what we're doing here. So for every x, we're going to replace it with our input values. 3 times 0 gives us an output of 0. 2 times 3 gives us an output of 6. 3 times 5 gives us an output of 15. So when x is 0, the output is 0. When x is 2, the output is 6. And when x is 5, the output is 15. These are our dependent values or our output values. So now we're going to work backwards. We're going to be given the output values and we're going to be asked to find the input. The input and output of a function table can be represented as a set of ordered pairs or a relation. In this lesson, the x values represent the input and y values represent the output. So just to recap, input is the same thing as the independent variable or our x values. The output is the same thing as our dependent variable or our y values. So we're going to use this and create ordered pairs. I wonder where ordered pairs are going to be displayed. So let's build towards that ordered pair type thing. Look at example number 3. It says find the input for the function table. We're going to use the work backwards strategy to determine the input. If the output is found by multiplying by 3, then the input is found by dividing by 3. So let's look at this. What are the output values? Our output values are 6, 15, and 21. So these are all what we get after we've applied our function rule to our x values. Okay? Well, we don't know what our x values are, but we do know what our function is. So what that means is we can take this function rule and set it equal to each of our output values, use what we know about solving equations to get back to where we start with our x values or our input. So what is the function? What are the output values? 6, 15, and 21. So the function rule, 3 times x, or multiplying by 3 is our function rule. So that means we can multiply x times 3 to get 6, x times 3 to get 15, and x times 3 to get 21. How can you find each input value though? Well, if 3 times x equals 6, that means we can go backwards or solve it by dividing. So we're going to divide both sides by our coefficient, which is 3. 3x equals 6. We divide both sides by 3. Our variable is by itself. So our input value, when our output value is 6, is 2. We do the same thing for 15. 3x equals 15. We're dividing by 3 on both sides. And x is going to be equal to 15 divided by 3, or 5. Notice how we're working from our output backwards to our input. And again, 3x, our function rule, equals 21, divided by 3 gives us 7. So our input values are 2, 5, and 7. Pause the video and try these on your own. Work backwards. You got a few extra steps here, but we can still get through it. Okay, let's see how you did for C. Now this one was a little bit more difficult. We had 2 steps to go through here, but we can still figure it out. Now our output is 1 and our function rule is 2x minus 1. So what we have to think here is what number times 2 minus 1 equals 1? Well, I know that 2 minus 1 is 1. So what can I multiply times 2 to still get 2? That would be 1, because 2 times 2, or 2 times 1 is 2, and 2 minus 1, is 1. So we're going to think the same way for the next one. So I need to get 3. So 2 times some number minus 1 needs to equal 3. Well, I know that 4 minus 1 equals 3. And if I need 4, that means I can multiply 2 times 2 to get it. So 2 times 2, which is 4, minus 1 equals 3. So my x value here is 2. And if I look here, I need to get an output of 5. So some number minus 1 equals 5. Well, I know that 6 minus 1 equals 5. So what number times 2 equals 6? Well, 3. So 3 I'm going to use as my x value because I know 2 times 3 equals 6 minus 1 equals 5. So this one, we kind of did 2 steps. We had to subtract and we had to multiply here to get back to our input values. So our inputs are 1, 2, and 3 because when we replace them into the function rule, we get the outputs that were listed, 1, 3, and 5. A little more challenging than the example, but still doable. All right, let's look at D. Same thing here. We've got to work backwards and we've got two operations to think about. So in our heads, we're thinking, what number plus 2 equals 17? Well, I know that 15 plus 2 equals 17, and 15 is 3 times 5. Well, if 3 times 5 gives me 15 plus 2 equals 17, then 5 is my value for x. I'm going to think, what number plus 2 equals 20? Well, that's 18, and I know that 3 times 6 equals 18, so 6 is going to be my value for x. And then the last one, what number plus 2 equals 29? And that's going to be 27. I know that 3 times 9 is 27, so 9 must be my value for x in the rule 3x plus 2. So we worked backwards to get to our input values, 5, 6, and 9. Look at example number 4. It says the Gomez family is traveling at a rate of 70 miles per hour. The function rule that represents this situation is 70x, where x is the number of hours. So 70 is the miles per hour, x is the number of hours. Make a table to find how many hours they have driven in 140 miles, 280 miles, and 350 miles. Then graph the function. Oh boy, here's where those ordered pairs come in. So it says, what is the function rule? Well, the function rule is 70x. So that means we're multiplying 70 times x. What are the output values? Our output values are 140 miles, 280 miles, and 350 miles. Okay? So that means 70x is equal to each of these in each of the input situations. How will you find the input values? Well, if 70x is supposed to equal 140, then that means I can undo the multiplication by dividing. So I'm going to divide each of these numbers by 70. Let's see what that looks like. Well, if 70x is supposed to equal 140, I'm going to divide both sides of my equation by 70 and get 2 as one of my input values. Same thing here, dividing by 70 on both sides, and x is going to be equal to 4. And in the last one, where our output was 350, dividing by 70 on both sides of my equation gives me 5. So my input values are 2, 4, and 5. And of course, if I wanted to check, I could always take each of those and put them into the function rule to get the same output values. So from there, my input and output values are my ordered pairs. So 2 and 140 make an ordered pair. 4 and 280 make an ordered pair. And 5 and 350 make an ordered pair. And of course, we can plot each of the ordered pairs on the graph. Across the x-axis, we have the hours from the input. And then on the y-axis, we have the miles from the output, or the distance. So I'm going to go over 2 and up to 140, and that's going to be my first input-output relationship. Next, I'm going to go over to 4 and up to 280, and that's going to be my second input-output relationship. And last, I'm going to go over to 5 and up to 350, and that's going to be my third input-output relationship, where input is x and output is y. All right. Well, I wanted you to try these on your own, or try this one on your own, but I kind of showed you the answer, so let's go through it. Brianna bikes 12 miles per hour. The function rule that represents the situation is 12x, 12 miles per hour, where x is the number of hours. Make a table to find how many hours she has biked when she has gone 12, 36, and 48 miles. Then graph the function. Well, in the problem, they give us the output values. They give us the miles. So 12, 36, and 48. We should have written those in first. And now we've got to think what our inputs will be. Well, if we're doing 12 times x, that means, that means we're going to multiply 12 times some number to get 12. Well, the only way we can get 12 by multiplying by 12 is to use 1. So 12 times 1 gives us 12. We've got an output of 36. 12 times 3 equals 36, so x value would be 3. And then we've got 48, and we know 12 times 4 equals 48, so our other input value will be 4. So here are our ordered pairs, 1 and 12, 3, 36, and 4, 48. So we're going to use that graph that was given to us, and we're going to graph each of those relationships as an ordered pair. We'll go over from 0 to 1 and up to 12. Again, we're going to have to guesstimate there where 12 is. And then we'll go over to 3 and up to 36, also kind of estimating where that one is. And then over to 4 and up to 48. Same thing, making 48 kind of close to 50, but not all the way on the line. So we've got our outputs we were given first. We used our function rule to figure out what our inputs are, and then we use those x and y values to create ordered pairs and graph. So now you're going to try these on your own. So your next move will be to complete the guided practice problems, numbers 1 through 3. That includes number 3. On your own, you're going to check your answers by scanning the QR code at the solution station and then going into Edmodo and doing the exit ticket for me.